Imagine a chef who skips every other task to focus on dicing onions at superhuman speed. That is exactly what an AI chip does. It is a processor built for one mission. It crunches the heavy math behind artificial intelligence through matrix multiplications and pattern recognition at blinding speed. This is not a general-purpose CPU juggling emails and web browsers. It helps models learn from billions of data points in hours instead of weeks. You hear the word AI tossed around like it is just software. Strip away the specialized silicon and the entire field becomes impossible. A modern language model demands the raw power of thousands of standard CPUs working in perfect sync. That massive army of processors generates just a single response. AI chips compress that massive workload into just one or two dedicated processors that run the math using a fraction of the power and cost. They turbocharge the math behind training, where models learn to spot patterns, and inference, where those models actually make decisions. From ChatGPT answering your questions to your phone guessing the next word, AI chips quietly run the show under the hood. Almost every tech giant has jumped into the arena. They are all fighting for the same slice of a market growing faster than anything else in hardware. NVIDIA currently holds the crown. Their GPUs took over as the default hardware for both training and inference because they crush massive parallel workloads. NVIDIA claimed the top spot at TSMC in January 2026 and pushed Apple out of first place. That single shift proves the entire industry is starving for NVIDIA silicon. Apple designs and builds its own M-series chips straight into every Mac. Apple just flipped the script in June 2026. They are skipping the high-end M6 chips entirely. Only the base M6 will survive for entry-level machines, while the rest leaps straight to an AI-focused M7 line for 2027 Macs. This marks one of the biggest changes in Mac silicon history. Even consumer computing is now being reshaped around AI capability. Beyond those giants, the roster is expanding fast. New players are flooding the market every single month. Google designed tensor processing units for its own artificial intelligence and now sells them as cloud computing power. Microsoft answered by launching the Maya 200 chip to run Azure AI workloads. OpenAI is wrapping up its very first custom artificial intelligence chip. Broadcom and TSMC are teaming up to manufacture it using advanced 3nm technology. Cerebras filed to go public in early 2026 with a wild new idea. They are building wafer-scale chips. The entire processor sits on one giant slice of silicon. Tesla designs its own full self-driving chips to power autonomous vehicles. Meanwhile, AMD is challenging NVIDIA in the GPU market. They are shipping powerful AI accelerators straight into data centers. The message is loud and clear. No major artificial intelligence company wants to rely on someone else's hardware anymore. Vertical integration has officially become the new arms race. Google calls them TPUs, or tensor processing units. They have been in development since 2016 and have already cycled through multiple generations. By 2026, Google is pushing both training and inference chips. The TPU V8 is leading that latest wave. Google plays a clever game with their strategy. They build TPUs for their own services first, like Search Gemini and YouTube, then sell that capacity on Google Cloud to outsiders. The clash between TPUs and NVIDIA GPUs defines the tech war of 2026. TPUs absolutely crush high concurrency and low batch size workloads, like serving AI agents that juggle many small requests at once. NVIDIA GPUs stay more versatile thanks to the CUDA ecosystem. They handle experimental models and custom frameworks that lack native TPU support. Tesla takes a completely different path by designing and manufacturing its own FSD chips in-house instead of buying from NVIDIA or anyone else. That strategic gamble paid off. Tesla's custom silicon runs neural network inference for autonomous driving while sipping far less power than off-the-shelf parts. By the 2024 model year, Tesla completely dropped NVIDIA drive hardware after the Model 3 refresh. They built their own chip design team and training infrastructure to make it happen. Think of the FSD chip as a tiny AI accelerator sitting right inside your car. It processes live camera feeds the instant they come in. You might be surprised, but the answer is yes. Gaming used to belong to graphics cards, but modern AI chips now pack features that actually upgrade your gameplay. NVIDIA Deep Learning Supersampling uses artificial intelligence to upscale lower-resolution images into stunning high-quality output. This technique dramatically boosts frame rates without sacrificing a single pixel of visual quality. Apple recently announced the M7 chip to prove consumer Macs can finally run large language models locally. Your computer will host an instant AI assistant that needs absolutely zero cloud dependency. Modern games now route physics and animations through dedicated AI chips. These processors generate realistic facial expressions and environmental reactions on the fly. AI chips deliver smoother performance and smarter non-player characters. They render visuals that completely outperform your raw hardware. It is genuinely the closest thing to a free upgrade you will ever receive. AI chips are no longer just for data centers and researchers. They now power your Mac, your car, your cloud services, and increasingly your gaming rig. The race to build better, faster, and more efficient AI silicon is the most consequential tech story of this decade, and it is accelerating fast. What single function do AI chips specialize in that regular CPUs simply cannot handle? They handle massive parallel math, like matrix multiplications and pattern recognition, which makes AI training and inference thousands of times faster. That speed advantage is why the industry is moving so quickly. What major product shift did Apple announce in June 2026 regarding its custom silicon? Apple will skip high-end M6 Mac chips entirely and jump straight to an AI-focused M7 line for 2027, while keeping only a base M6 for entry-level machines. Why does NVIDIA still beat Google TPUs in 2026 for certain workloads? NVIDIA's CUDA ecosystem handles experimental models, custom architectures, and frameworks without native TPU support, with unmatched versatility. TPUs excel when you need to serve high concurrency and low batch size requests. If that made it click, subscribe. We break down the frontier of tech and AI every day.